Hi, this is Gurumurthy, working as an associate professor from KPR Institute of Engineering Technology, Coimbatore. In this video, we will talk about the modulation and we will see that what is modulation, so why it is used in the communication and what are the different types of modulation. And so in a broad sense, communication is the exchange of information either wired or wirelessly between 2 points which are far away from each other. So this information could be a voice signal or email or even a television signal. But here let's take the example of the voice signal. So if we consider the speech signal or the human voice signal, then it contains the frequencies up to the 3 kHz. If we consider the entire audio spectrum, it varies from 20 Hz to 20 kHz. So this low frequency or message signal is known as baseband signal. And if we want to transmit this baseband signal to a far distance, then there are some challenges. So we will talk about these challenges a little later. But thing is, the baseband signal can not be transmitted directly. But with the help of high frequency periodic signal, it can be transmitted. So this high frequency periodic signal which carries this baseband signal is known as the carrier signal. So, but the question is how to impose this message or baseband signal onto a carrier signal. Now we know that any signal has three basic properties: amplitude, phase and frequency. So modulation is the process of where one of these properties of the carrier signal, like the amplitude, phase or frequency, is changed according to the baseband signal. And based on which property is changed, there are different types of modulation. Why this modulation is important? So first reason to use this modulation is to reduce the antenna size. So when the signal is transmitted wirelessly, then size of the antenna is very important. Then size of the antenna is proportional to the wavelength of the transmitted signal. And depending on the type of the antenna, it is the fraction of the transmitted wavelength. And let's say size of the antenna is equal to lambda by 4. Now the relationship between frequency and wavelength can be given by the following expression. So for example, if a transmit signal has the frequency of 10 kHz, then its wavelength will be equal to c divided by f. That is equal to 3 into 10 to the power 8 meter per second divided by 10 kHz. If we calculate the wavelength, then it will become out 30,000 meters. And if the size of the antenna is quarter of the wavelength, then the length of the antenna will come around as the 7,500 meter. And this size is actually impractical, right? On the other hand, if the signal is transmitted and let's say 10 megahertz, then the length of the antenna will reduce by the factor of 1000. So that means in that case, the length of the antenna will be equal to 7.5 meter. In fact, the size of the antenna is manageable, right? So that is the one of the reasons for the modulations. Then second reason is to reduce the interference. So just imagine in a single room, if there are three persons are talking to a same persons, then the persons won't get anything, right? So similarly, let's say if you 5 different voices signals are around the same frequency range are transmitted without the modulation through the single channel, then there will be an interference between them. And at the receiver end, we won't get any transmitted signal. But instead of that, if a signal is modulated at a different carrier frequency and all the carrier frequency are relatively far away from each other, then there won't be any interference. And all the signals can be demodulated at the receiver and the message signal of each transmitter can be retrieved. So using the modulation, the interference can be reduced. And same time, the multiplexing of the different signals are also possible. And the example which I showed you earlier is the frequency division multiplexing, where the different message signals are demodulated at the different carrier frequencies, and because of that, they can be transmitted simultaneously. So these are some of the important aspects why the modulation is used in the communications. So now let us see the different types of modulation. Broadly, there are two types of modulations. One is the analog modulation, another one is the digital modulation. If there are message signal is analog, then it is known as the analog modulation. And similarly, if the message signal is digital form or in terms of ones and zeros, then it is known as the digital modulation. Then first of all, let's talk about the analog modulation. Then based on the type of the carrier signal, this analog modulations can be further classified into two categories, that is continuous wave modulation and pulse modulation. So if the carrier signal is the continuous wave like a sine wave signal, then it is known as the continuous wave pulse signal, then it is known as the pulse modulation. And first of all, let's see the different types of continuous wave modulation. So mainly there are three different types of modulation, that is amplitude modulation, frequency modulation and phase modulation. So in case of amplitude modulation, amplitude of the carrier wave changes in according to the message signal. If there is this is the message signal and high frequency carrier signal is the carrier signal, so then the amplitude modulated wave would be look like this. So as you can see, this shape of the carrier wave changes according to the message signal. So similarly, in case of frequency modulation, frequency of the carrier wave changes according to the message signal. So with the increase in the amplitude of the message signal, the frequency of the modulated signal will also increase. Similarly, with the reduction in the amplitude, the frequency of the modulated signal also reduces. And similarly, in case of phase modulation, the phase of the modulated signal changes according to the message signal. So in the upcoming video, we will talk about these different types of modulations. Alright, let us see the different types of pulse modulation techniques. So mainly there are four different types of modulation techniques, that is pulse amplitude modulation, pulse width modulation, pulse position modulation and pulse cone modulation. So let us briefly all these techniques one by one. So in all these modulation techniques, the message signal is the analog in nature, while the carrier signal is pulse train of the finite frequency. So in case of pulse amplitude modulation, the width or duration of the pulse will remain the same, but height of the amplitude of the pulse signal will change according to the message signal. So similarly, in case of pulse width modulation, the height or amplitude of the pulse will remain same, but width of the pulse will change according to the message signal. So here the message signal amplitude is sampled at the rising edge of the each pulse, and the width of the modulated signal is proportional to the sampled amplitude. So in fact, the pulse width modulation, I have already made a separate video. So for information, you can check that. So similarly, in case of pulse position modulation, the width and amplitude of the pulse will remain fixed, but position of the modulated signal will change according to the input signal. So at the each rising edge, the message signal is sampled, and based on the amplitude of the input signal, the position of the modulated signal will change. That means the amplitude of input signal increases, then this is the modulated pulse will further go away from the reference position. So in fact, it can be generated with the help of the PWM signal. So that means generating the pulse at every falling edge of the pulse PWM signal, that this PPM signal can be generated. So alright, now let's move to the next modulating scheme. So in this pulse cone modulation, the message signal is sampled at the finite interval, and the sampled value is quantized using the quantization process. And then the analog using analog to digital converter, the message signal is encoded. For example, if the sample value is encoded in 5 bits, then for every sampled value, we will get a pulse code of 5 bits. This is a brief overview of the pulse code modulation. But in future videos, we will describe about some pulse code modulation in detail. And alright, so far we have seen the different types of analog modulation techniques, where the message signal was in the analog in nature. But similarly, let's talk about some digital modulation technique. Then it's every broad sense. Mainly there are three different techniques are available. One, amplitude shift keying, phase shift keying and frequency shift keying. So in all the digital modulation scheme, the message signal is in digital form. And this amplitude shift keying, so one form of digital amplitude modulations where the amplitude of the modulated signal changes according to the digital bit stream. So in this scheme, binary 1 is represented by the fixed amplitude of the carrier's wave, while the binary 0 is represented by 0. So similarly, in case of frequency shift keying, frequency of the modulated signal changes is according to the digital bit stream, Here binary 1 is represented by one frequency, and while the binary 0 is represented by a different frequency. So likewise, in case of phase shift keying, the phase of the modulated signal is changed according to the digital bit stream. So in a binary phase shift keying, binary 1 and 0 are represented by a different phases. So and to be precise, there are 180-degree phase shift apart from each other. So when there is a transmission from 1 to 0 in the message signal, from R1 from 0 to 1 there is a message signal, then there is a 180-degree phase shift in the modulated signal. And that is a brief overview of the phase shift keying. So in a summary, we have seen that what is meant by modulation, so why it is used, and we have briefly discussed about the different type of modulation techniques.